Welcome to Glow Your Own. It's the second session of this online coding workshop. We're building on last week's coding to build something more sophisticated. I'm going to pass on to Sophie and we're going to get going with the coding. Thanks so much.
Fantastic. Thank you, Dane. And hello, everybody. It is lovely to see you all again. And I'm very excited that today we are going to start building in real life. So we're going to be starting to create our lights that are eventually going to form part of our beautiful Christmas lanterns. So it should be a really good, a good session. So if you all could grab your Arduino boxes, and what we're going to do is we're going to take the circuit and the code that we created last time, and we are going to make that in real life. And then once we all do that, we're going to try and see if we have time to make some more complicated and fancier, prettier things as well. So I will just share my screen to show you Tinkercad so we can look at seeing what we're doing. So can you see my screen, everyone? Yeah, great. So if you head to the Tinkercad classroom, I'll just pop it in the chat. Someone, except, sorry, I'm on two screens today and I've lost my mouse on one of them, which is very exciting. Here we go. So I'm just popping the link to the Tinkercad classroom into the chat for all of you. Here we go. So if you click on that link, you should see this page. And then we join with nickname, and you should all have your nicknames ready. They were in the email. If you have lost the email or if you've forgotten what it is or you're not sure, do pop something in the chat and we will be able to help you. Okay, so my nickname is Sophie. That's me. Then it thinks about it for a minute. And it comes to the designs of the circuits that we've built previously. So if you go down to circuits, you can see the circuits that we created last week. Yeah, so you just have to click on the circuit that we created last week. I called mine Glow Your Own session 1. You might have called yours something a little bit more imaginative, but I tend to be quite boring when I'm naming things because it makes it easy for me to find them afterwards. And then you just click on the button in the top that says Tinker This, and then it will open up our circuit for us. Like this. So you'll remember this circuit where we connect our controller, our Arduino, with an LED light, and back to the Arduino. And then we coded it over here to make our LED turn on. Over here to make on. Sorry, I think there was some echo going on there, but hopefully you'll have heard that. So everyone just pops their hand up or pops something in the chat where you have got to your original circuit, then we will start to make it in real life, which I'm very excited about. All right, let's get started. So this is the circuit that we're going to make. Very excited about it. I'm just going to hide the code for a minute and zoom in. Oh, sorry, I zoomed in too far. There we go. So the first two components that I want you to get out, you might need to unbox them. One is your Arduino. It looks like this, or similar to this. You need to get that out. And that's our microcontroller. And you want, so our thing that controls our other things. And then we want our breadboard. Dane's got his, excellent. And this is where we're going to put our all of our electronic components. So it's all going to connect up nicely. So make sure you've got all those two things out and ready to plug stuff in. All right. Now, the first component that we're going to put in is our LED, or our light emitting diode, our light, which looks like this. You can see this tiny little light bulb. Oh, sorry, I'm not holding it very well, am I? There you go. It's got two legs. These little bits of wire, we call them legs. And one of them is shorter than the other. Now you can see on the Tinkercad, one of the legs of our LEDs is kind of kinked at an angle, and that's because current will only flow one way through our LED. So we're going to take our LED and we're going to pop it on our breadboard. So it doesn't actually matter where you put it on your breadboard, as long as it goes across two of these columns. So the columns are numbered, so 15, 16, 17, and it goes one leg in one leg in the other, just like on our circuit diagram. So yeah, you can see that. Yeah. All right, if you do have any questions, any problems, pop it in the chat. And we will do our best to help you. I'm just going to spotlight myself and Dane, I think, for now, so that it makes it a little bit easier for you to see our Arduinos when we're holding them up like this. Okay. Sarah's also popped some advice in the chat for how to make our pictures bigger if you would like. So once you've got your LED in, we're going to pick our resistor. So that's this bit here on the Tinkercad drawing. And the resistor looks like this. It's really small, looks like a weird little bug with two legs. You can see Dane's is a different color to mine. It does depend what box yours comes in as to what color they are. Now, if they are labeled, then sometimes they're labeled with a value, and you want to pick one that's about 100 ohms. If not, don't worry too much about that. We can always change it to fix that later. So what we're going to do is we're going to put our resistor in the same place that it is on our circuit diagram, okay? So from one of the legs, it'll go on the same column. So like here, my resistor is in column 11. And so it's going to go in that same column. And then it's going to go to the row with the blue line, like that. Can you see? It goes from there to the blue line. All right. So it doesn't matter which column it is in, but you do have to make sure that they are all connected. So you can see here, you've got these little numbers. If I zoom in a little bit more, you can see that all of the columns of the breadboard are numbered. And so my LED is connected to column 11 here. You can use the same columns to make it easier, so it's easier to follow along, or you can pick your own. All right. So mine's in 11. And now we're going to connect up to the Arduino, which is very exciting. So let's take one wire. I'm going to pick an orange wire this time. You can change the color of your wire on this Tinkercad just by clicking on the wire and then changing the color if you like. And that is going to be this wire here that goes from the blue line on the breadboard to the little pin in the Arduino that says GND. And I'm sure you'll all remember that that means ground. So that means ground, okay? So it's going to go from the blue line there. You can see. And it's going to be connected up to the pin that says GND or ground. I can't quite, there you go. Okay. Now I'm going to pause here for a minute. If Dane keeps holding his up so that everyone can see, and it should be, thank you, Dane. So it should follow this. So you've got an LED, a resistor, and a wire that is connected to ground. If you do have any problems, Sarah's answering some in the chat, so it doesn't matter if your breadboard doesn't have numbers written on it. Sometimes they don't, sometimes they do. It just matters that it's in the same, your resistor is in the same column as your LED, and it's connected down to the blue line, the negative line. All right, and then our wire goes from that negative line, which I'm highlighting here, all the way to the Arduino, to a pin, to a hole that says GND, which stands for ground. All right, so when you think you're there, pop something in the chat or pop your hand up. We've gone quite quickly through that bit, so we'll give everyone a chance to catch up. If you do have any questions, pop it in the chat. You should have 3 components in. Brilliant. Some people are already there, I think. That's amazing. Excellent. Great. So you're getting there. That's good. We'll give it a bit of time. Just so that everybody is up to the same point. Do remember that if we are going a bit fast, this is all being recorded so that you can watch the recording. Dane gets them up super quickly because he's very efficient. And then you can pause us at any point, make sure you're up to the right place, or you can fast forward us. If once you've got to that point, you're like, no, come on. So if you're just babbling now, you can fast forward to the next step. All right, so I'm just gonna go through it one more time. So we've got our LED, which goes across 2 columns. All right, so mine are across column 10 and column 11, but yours can be across whichever columns you want. And you can see that here in the circuit diagram, our LED across these 2 columns. Then I've got a resistor that goes from the same column as the LED to the blue line. So it goes from here to the blue line, up like that. And then finally, I've got a wire that goes from the blue line, my orange wire, all the way to the little hole on the Arduino that says GND, which stands for ground. The others are being amazing and popping in some helpful tips and hints. So do check the chat if you would like. We've just got one more wire before our circuit is complete. Okay, so I'm going to go and grab that wire now. And that's this wire that I will just highlight on my diagram, on my circuit diagram. So I've got a new wire, I've got a green wire to do that, put that in. So it's going to start in pin 7 of my Arduino. So I'm going to pop that in the hole that says 7. Sorry, your eyes are probably better than mine and you can look at it. You can see the small bits a bit more easily. So I've got pin 7 on my Arduino, and that's going to go all the way to the other leg of my LED, to the same column as the other leg of my LED. So the leg that isn't connected to a resistor. Oh, so it's a bit tough to put in, but that's okay. So it goes from pin 7 up here into the same column as the leg of my LED. All right. While we pause for a minute so everyone can catch up, if you do, when you have got all of those components all connected up, do pop something in the chat or raise your hand. Let us know if you do have any questions or any problems, do pop it in the chat, and the others can help with that. But while we're waiting for a minute to get everybody up to speed, up to the same point, just going to say a few quick things before we connect our circuit up to our computer, which is what we're going to be doing next to give it some power. Now, our Arduino is very low power and it's nice and safe, but it's always the best idea not to fiddle with an electric circuit if that circuit has power. All right, so if you're changing the light bulb, to turn the light switch off before you change the bulb. And we're going to do that same thing every time that we are using our circuit. So if we want to change any of our lights or any of our wires, we're going to make sure that it is not connected to power, so the computer, which is where we're going to get our power, before we do that. And that's just to make sure that everyone remembers to keep safe and to follow the nice safety rules to keep us all safe. Like I said, this is very low power. We're all fine with this, but the kind of circuits that some of the others work with, Tristan works with or something, you could hurt yourself if you were like, I'm going to pull out this resistor or something while that circuit has power. And we don't want Tristan to hurt himself. So we're going to make sure that we always disconnect our power. The other thing I'm going to remind you of is that these components are quite fiddly and small, which is good because we want to stick them inside our Christmas lanterns, so it'll keep them nice and safe. But it does mean that you need to take care of that. You'll keep track of all of them. Don't drop any of them on the floor. Make sure that they're not around for any pets to eat up or for any small children to be like, that looks tasty. I shall try back to put it in my mouth to see what this wire tastes like. We don't want anybody eating any wires. But make sure that you're all tidied up. Okay. So question, how is everybody doing? Have you got all of the components? So you should have 2 wires connected to your Arduino and to your breadboard. And then it goes to the LED and a resistor as well. If you have, Dane has, excellent. Just pop a thumbs up or a thing in the chat. Excellent. Good, we've got some people there. If you do have any questions or if you're not quite there, then again, write a question in the chat. And Sarah and Tristan and the others will all be able to help you. Okay. Oh, some smiley faces. An old school smiley face. I like it. Brill. Okay then. So our final check before we connect our power up. So we're just going to trace the path of the circuits all the way around, because I remember we talked last time about the fact that we need a complete circuit. So there needs to be a path for the electricity to go around, or it will get stuck, and then it will be like that would be terrible, and it wouldn't work. So we're going to start at our Arduino, and then we're going to go along our green wire to the breadboard. My green wire is connected to the same column as my LED. Then it will go all the way up to the LED. We'll go through the LED, Then on the other column of the LED, it goes to the resistor, which goes to the blue line on my breadboard. And the blue line on my breadboard is connected to my orange wire, and my orange wire is connected back to ground in the Arduino. So it's got a complete circuit for it to go around, just like in the diagram. Okay, now we are going to connect up our Arduino, which is very exciting, to the computer and send it some instructions. So in your kits, you should have a wire. Looks, well, mine is nice bright yellow, and it's got a USB, an old school USB connector on one end and a square connector on the other. Other people can probably tell me what type of USB connectors they are, but we've got a square one and a rectangle one. What you want to do is take the square one and pop it into the Arduino. Okay, so you can see that I've got this metal, oh, sorry. I'm going to hold it a different way so you can see a bit better. I've got this metal thing here at the top of my Arduino, and I'm just going to put my wire into that, like that.
And there's a different design that some of you might have, which is a slightly narrower, smaller USB type, which again probably has a name. I think it's a USB-C or something, I'm not sure, but that should just go into the connection on the Arduino itself. So instead of the square, the big chunky one that Sophie has, you might have a slightly slimmer
little
one that looks a little bit like that.
Yeah. But either way, there's a connector on your Arduino that will connect into it. Then you take the other wire and you connect that to your computer. So through the USB port, through a USB port, or the USB-C port, or whichever one it is. And that bling, bling, bling was me connecting my Arduino to my computer. And you will see that now it's connected. I haven't given it any instructions yet, so it's not doing anything, but you can see that at the top, there's this little green light. And I think, has Dane got one? Have you got one on yours, Dane?
I did have. I'm just going to unplug it and plug it back in to make it do it again.
There, you see, so it flashed. And it's like, oh, yep, all right, I'm connected. I know what's happening. All right, so connect it up and you should get a nice green, some nice lights on the Arduino itself that just say, oh, I'm working, I'm getting power, that's good. All right. Now is my favorite bit, because we get to send it its instructions. And well, according to my little brother, I'm very bossy and I like telling everything what to do. So I like the coding because it means I can tell computers what to do. So you'll remember in the code over here, I just had a nice simple bit of code that was going to set my pin 7 to high. So I was going to send a message to pin 7 that said turn on. All right. And my green wire is connected to pin 7 on my Arduino. So that knows, so that I'll be sending the things to the right pin. Now, we're going to, this is a really nice, what we call language, a nice way of giving it instructions, but we need to talk in a slightly different language when we're going to send those instructions to our real Arduino. So if you come up here to the bit that says blocks and click on that, you can change it from blocks to blocks plus text up here. And then another bit of code comes out that's all in words. And it's just in a different language. It's giving exactly the same instruction, but in a different language. So it's like me saying bonjour instead of hello, or guten Tag instead of good day. Just a different language to do it. And it's actually quite easy. So some of the words are a bit like, why are you talking about voids? That's a bit weird. But if you just look at it, so it says digital write, we're going to send an instruction, write down an instruction to pin 7, and our instruction is high. So it's just the same as in here, really. All right, and what we're going to do is we're going to copy this and put it onto the Duino app. So I'm just going to get the Duino app, the link to the Duino app for you. I'm going to try. Sorry, I'm looking at a big screen that's all the way over there. To copy.
You got it?
Yep, I've got it. So everyone, but Sarah has beaten me because she's amazing. Thank you, Sarah. So yeah, so if you all open a new tab on your browser, so you can see I've already opened my new tab on my browser, and you can put that address in, you get to this. And it tells you that some things have changed, but that's okay because they've just changed in good ways. I'm going to click OK to that. And then it says, welcome to the Duino app. And this is a really cool website because it means that we can send the instructions that we've made in Tinkercad to our Arduino. Why we're going to do that is by clicking up here on code. You see in the top left, it says code with some curly twirly brackets. We're going to click on that. And I clearly had been doing something earlier in Duino, which is fine. So yours will come up with a thing that says you can write some new code. Let's see if I can get to that point for you. So it will ask if you want to write some new code. And you say, yes, please, give it a name. And then delete everything that comes up in here. So it gives you some code to start off with, but that's not the code we've done. We've already done our coding. So you should end up with something that looks a bit like this. Okay. So everyone raise your hand or pop something in the chat when you are here. Well, we've got some raised hands already. Dane has done it too.
Well, so if your code's been deleted, if you could just paste it again.
I meant to delete it.
Oh, sorry.
I just said delete any of the code that's in there, because we're going to take our own code and do it in a second. I just want to make sure that everyone has got this nice blank bit to start with. Brill. So remember, yes, so do click create new project. Yours might, so because I looked at mine earlier today, I think I had already created a new project. I'm really sorry about that. I thought I'd deleted it. So when you get to, when you press code, it'll come up with a box that says create new project. And you just say, yes, create new project. You can give it a name. If you want, you can give it a description that says glow your own session 2 or something. And then you click create. Okay. If you do have any problems or any questions, then pop them in the chat. Remember that we're recording, so you can always just pause us if you would like on the recording. And so pop your hand up when you have got you're on the Duino app like this, or pop an emoji in the thing, in the chat. Sorry, not in the thing, in the chat. I'm going to use real words. Yep, so it will come up with some code automatically. You can just delete that all because that your code is better than the code that it does automatically, the code that you've already written. And then you should be left with a blank bit of code here. And what we're going to do is we're going to go back to Tinkercad and we're going to copy all of the code that you wrote. All right, so this text code, C+ here, you just highlight it all and then do Control-V like you would. You can also right click and press copy. That should work too. So you just want to copy all of that and then go to the Duino app and put it in here. So it says you can see, you can recognize that this is the same code that was in the Arduinos. All right, we just have one more step before we're going to send our Arduino code, or our Arduino its instructions. Okay, so this is the best bit. And what we need to do for that is to make sure that the computer knows it's talking to an Arduino. So you can see down here, it says select device, okay? If you click on that, it will come up with some options, all right? And one of them should say something like Arduino Uno. So mine is an Arduino Uno. You might have slightly different types of Arduino, so it might say something a bit different. So it might say Arduino, or what are the names of the Arduinos that you've sent out, Dane? I can't remember.
So there's a Freno, but it still comes up as Arduino Uno. It's
awesome.
It's the same.
Brilliant. So you just click on that and then say connect, please. It's always nice to be polite to computers, to everyone really. If you want to all right, I'm just going to go through that again in just a second. So we've got we're on Duino.app. We've created a new project in our Duino.app. In the Tinkercad, we highlight all of the code, all of the text code here that we get by changing this little thing from blocks, which is what we created last week, to blocks plus text. You copy all of this, so you can highlight it all and then do right-click copy. Then you go to the Duino app, you delete anything that's in there already, and you do, and you press the wrong button on your keyboard, and then you do Control-V for paste. Or you can paste using whichever command shortcuts you like to use, you have on your computer. Okay. And then you need to make sure in the bottom right, sorry, I told you that I would keep doing this because I don't know what right and left is. On the bottom right, you click on serial and make sure that it is connected to your Arduino. So once it is, it should say paired next to it. That's how you can tell. Brilliant. So let's see how everyone is doing. If you are ready for that final button press that will send your code to your Arduino, then raise your hand or put an emoji in the chat or do a thumbs up or something. While we're waiting for people to be ready, great, can see some of you are. Just as a reminder that down at the bottom is where you make sure it's connected to your Arduino, that it's what it's going to talk to. So you've got one that says server, which you don't have to worry about, one that says what type of microcontroller you're using, which is automatic, and then the next one is here. So it's at the bottom near the right, and you just want to make sure that it's connected to the Arduino. So you can see it says paired there. And then click connect. All right. Ooh, are we ready? Dane, are you ready? Oh, Dane's not unmuted, so I'm guessing not. We're going to give Dane a minute.
I am ready, sorry, yes.
That's good. All right. We've just had a quick question that I'll go back to. So in Tinkercad, the way you get this C++ code, that's the name of the language that we're using, C++, because we're really not very good as at naming things. C++ is not a very exciting name. Once you are on the code, you will probably just see this that says blocks. So this is the code that you created. All right. If you go over a bit above where you've got all of your different commands that you can use, it will say blocks. If you click on that, you can go down to see blocks and text. And that means you can still have the blocks, you can still see your blocks, but you can see what code, what that looks like in C++. All right, we're all doing really well, honestly, everybody. And you just copy this into Duino, which is over here. All right. Fantastic. Well done, everybody. All right. Any problems, do pop it in the chat. Sarah's doing a fab job of connecting them all up, of answering them all. Now, this is the best button. Well, this is my favorite button. Up in the top right-hand corner, there's a whole bunch of different things. One says, if you hover over one with the tick sign, it says check and compile. And if you hover over the one next to it, which looks like a play button with a little thing underneath it, I'm not sure what it's supposed to be, but anyway, it says compile and upload. Now, compile is a fancy term for the computer thinking about something. So it's the computer taking this language that we've written into it and saying, all right, well, that means do this and then this and then this. So it's computer thinking time, basically. And then upload means send it to the Arduino. So send it down the wire that you're connected to and make that and do that instruction. All right. So that's the one that we're going to try and we will see if it works. All right. So everybody click this compile and upload button, this one, the triangle and the square. And something comes up here. It says compiling. So it's thinking about it. It's sending it. And it says 100% done. And then your light should be on. Mine isn't, which is a bit sad. But, you know, I've just done something wrong. That's okay. It normally goes wrong for me first time.
No, mine's not working.
Oh, no. All right. Does any so
whose is working? Oh no, oh dear.
Pardon?
Whose is working? Have we got some trouble or is it? Oh no.
Whose is working? Let's see. Is anybody's working?
Oh. Okay. Should we go through the steps again?
Yeah. Or... So there are a couple of things. So it often doesn't work the first time. Oh, somebody's is. Hooray!
Yay, great.
You're all amazing. You need to tell us how you did it, how you got it. Honestly, because mine is like, no. Oh, I know why mine's not working. Because I have not connected it properly. Because my resistor had just fallen out. So one thing to check if yours isn't working is that all of your components are firmly in the little holes on the breadboard, because sometimes the wires are quite long and it's quite easy for them to get for them to be not, they look as if they're in and then they're not, and so there we go. What I had done, so you can see that my light is now on. Yeah, can everyone see that my light is on?
I can. That's good.
Excellent. So what I had done is when I had put my when I connected my Arduino to my circuit, I must have knocked my resistor out, and so it wasn't connected into all of the little holes, and now it is, which is great. So now it's working. But I took out. And so what you should do to start with is to check that all of those components are firmly in. So they're firmly plugged into the breadboard, and they're firmly plugged in to the Arduino as well. Okay, so if that is all working, if they're all nice and firmly in and it's still not working, then the most common, another very common thing is, do you remember earlier we talked about how our lights, our LEDs, or light emitting diodes, only let electricity flow through one way? Yeah. And so sometimes, often, we put them in to the wrong, you put them in the wrong way. So if your Duino app says that it's 100% done, then that's good. It's sent that instruction to the Arduino, but there's probably something wrong with your circuit. So unplug your Arduino, take your LED out, turn it around the other way so that the legs are attached to the are in the different ways, and then plug it back in and try uploading again. All right, so you can see that mine is now working, and I'm going to unplug it. That was me unplugging it. I'm going to turn it around the other way. So I've just twiddled it around so that the legs are in the other way. And now I'm going to plug it back in. And you can see it's not on. And I can send it again. Send my code again. So it's 100% error. So it's really sad because I unplugged it. So I just connect it again, compile and upload. And now it's decided it's going to crash. But anyway, so it's because I changed my circuit around, and that caused it to be a bit sad. So let's see how you're all doing. Well done to everybody that's got it all done. So what we're just going to do is we're going to connect we're going to show you again how that we connect our Arduino to our computer. Sorry, I forgot the word for computer. We'll start right from the beginning. So I'm going to start a new tab and do Duino.app. Click on that. So it's, oh, things have changed. I know, it told us last time. Click OK. And then you pop over here to code. It will probably remember your code because it's pretty good at remembering things. You need to plug it in. That was me plugging it in. And now you see down here, it says select device. So down here at the bottom right, it says select device. All right. So you click on that. And can you all see the thing that has popped out of my screen, or should I share my, or do it?
You can see it.
The pop-up thing, good. But it turns out that Dane's face is covering it now. So I'm just moving you to the other side of my screen, Dane, sorry.
I'm sorry for being in the way.
That's all right. Click on Arduino Uno. And then you click connect. Yours might not say Arduino Uno COM25, but it should say something to do with Arduinos. And then you can see down here at the bottom, it says that it's been selected. All right.
So one of the things that sometimes is helpful if it's not working is to unplug your USB. And if you have a second USB on the computer, try it in that one. But even sometimes just unplugging it and plugging it back in, there's enough to trick it. And that's what's happened with me. So I've got mine uploaded now and it's flashing.
Yeah.
So
Jane had a fancier one
from last time. So I think it's really good to kind of have mistakes or problems or little technical surprises, because it means that, well, you know what to do next time. So if you have managed to get it working now and it wasn't before, great. If it's still not working, we'll get it working and we'll find out how to make it twinkle or turn on at least.
Absolutely, yes. So one thing about coding is, mine at least, never works the first time. All of the people who work here on site, I don't think any of their code works the first time, or their first circuit.
So someone said that their Duino was coming up with 100% error rather than 100% done. So I would be tempted to unplug the Arduino from the computer and possibly even unplug it from the Arduino, so your wire is not attached to anything, and then revisit the Duino.app website like Sophie did before, just refresh the screen, and then maybe plug back in your various USB things, and sometimes that tricks it to go, haha, it's worth having another go. So if it says 100% error, so reselect your USB port. It might not say Arduino COM, it might just say USB port. So the one that's got, because it might have a USB, it might have a Bluetooth connection, and it confuses the Arduino which one to search for. So just make sure it's a USB. If it doesn't say Arduino, try it anyway. I don't think mine said Arduino actually. And then you can select your Arduino board. So serial port is selected, your Arduino board is connected. Hopefully it will pick it back up. So I think more people are getting success, which is good.
Excellent. That's amazing.
But a few things that I'm struggling to help with, we think we're going to have quite a lot of troubleshooting to do later. So everyone, if I'm not being very helpful in the comments, I'm very sorry. We will fix your problems in the last half an hour when we can share screen. So don't panic, we will get it done.
Absolutely. Yes, thank you, Sarah. I think somebody just popped in the chat if there was going to be a recording. There absolutely is, and then you can pause us all and get to the same stage if you want to, if you can't stay for the troubleshooting. So sometimes lights do turn on, but they are a little bit faint, especially if you're often with a blue LED, then they can often be quite faint, which is why I chose a red LED. My room is really bright. My lights are really bright. Sometimes it can be hard to...
It can also be the value of the resistor can affect it, which I know, because you said in the packs we get, some people may put 100 ohm ones, but they also may put like a 1 kilo ohm or 10 kilo ohm one, which would make the light dim.
Yeah.
Just watch out for that.
Absolutely. So as Jamie said, what the resistor does is it reduces the amount of power that the LED gets, which is a good thing because we don't want it to be too bright and blind us all. But if we choose one that is too strong, then it can make the LED really, really faint. Okay. So we have a few more minutes, and I think that we were going to, and we've got the before we start troubleshooting.
Mm-hmm.
Yes. So, and I think that Tristan has something to show us. So I'm just going to stop sharing my screen for a minute. I will stop. I'll stop sharing and have a look at the chat, and maybe if I add a spotlight to Tristan to make Tristan big, he can show us. Hooray! Sorry, I mean, obviously it's hooray that you're big now, Tristan.
They told me it would happen one day.
Somebody's work.
So yeah, I've been messing about with more LEDs wired up exactly the same way, but more of them. And I've used the code block that we've been using today and the weight code block that we were introduced to last week. I've come up with a little, I wonder if you can see it properly, a little LED rainbow. Yay! It only uses stuff that you've seen so far. So if you really wanted to mess about after the session and see if you can come up with your own, then I'm sure you'd be able to from the videos we've got up already.
So I will share my screen again so that everyone can see where we are. All right. Now, I think that I saw someone saying that they didn't have the code for Tinkercad. If you don't have your nickname for Tinkercad, drop us a message in the chat because we can find that for you super easily. If you don't have these yellow blocks in Tinkercad, then that might be because you accidentally, instead of switching to blocks plus text, you can go just to text, and you can actually write the code in this other language if that's the language that you want. But that does mean that you don't go back to the blocks. So you just end up with this. But if you want to go back to the blocks, we were doing a super easy, a very nice, simple bit of code to start with. You can go back to blocks and it will let you start again. So you just can remove these, pop them in the bin at the bottom, enjoy the cool sound, and rewrite your code like this. So we wanted to turn our LED on. So that was in output. We wanted to set the pin to high, but it wasn't connected to pin 0. Mine was connected to pin 7. Oh, sorry, I pressed the wrong pin 7. And we wanted to do that forever. So we were going to use a forever loop. And then you get back to the blocks plus text. So you can see the text here as well. Okay. So you have, it's so amazing that you have all persevered and done all of these and done all of the coding and the building the circuits and sending it to our real life Arduino, which is fantastic. If it's not working, that's absolutely fine. You saw mine didn't work, Dane's didn't work. You just have to persevere a bit to get to the that satisfaction of we've got a light and it's turned on like this. Oh, you can't even see that it's so bright in here, sorry. There you go, you can see that it's lit. So you should all feel very proud of yourselves. I think we're going to move over to troubleshooting in a minute, but Dane, do you want to wrap up?
Sure, thanks so much, Sophie. That's great. Tristan, I love the adapting it and building a bigger LED sequence. We've had quite a few comments in the chat box with some trouble that people are having, and we'll fix that in a few minutes. It might just be, sometimes it is just unplugging it and plugging it back in again. And so we will put this recording up, and there is the two help sheets. One is on building the circuit, and the other one is using the Duino.app. So it might just be, if you have a quick look at those, the answers will become clearer to you as well. But please stay behind if you can, and we'll help you. And also, if you've made it work, we always want to see people succeed. So we always want to see people who have managed to make it to work correctly. But thanks so much for coming. Please do come back next time where we'll take this a step even further, and you become more and more confident with these digital tools to make your creations. Thanks all everyone for helping, Sophie, Sarah, and the whole big team. And we'll see you next time. Bye.
Bye, everyone.